In this lecture, we're going to be looking at creating graphical user interfaces for Java applications. I do want to say at the outset of this that I will be moving at a rather brisk pace. The purpose of this lecture is just to give you some overview of GUIs, some terminology to be aware of, and then you will learn most of the details as you start developing GUIs, and then as you need to do specific things in your particular GUI, you'll learn like how to do a JFile chooser, how to do different options, but you'll just learn those as you need to incorporate them into your applications. A GUI. A GUI is just a graphical user interface. It is a way to interact with a program. Remember here, it's not the actual program itself, or what we call the brains of the program. It is just a way to interact with it. So far, we have been interacting with our programs through a text base or console, but we want to migrate into being able to interact through a GUI. I will say that creating GUIs does require substantial effort. There are some studies that have been done that on large applications that just developing the GUI can take up as much as 40% of the development time. Java does provide a lot of classes to aid in the development of the GUI. The swing framework is what you'll hear. Now, I do want to mention here, applets versus applications. Both are GUI programs. Applets are programs that run inside a web browser. And so that code, when you go to that website, is actually downloaded in your web browser and it's executed there. Applets do have limitations on what they can do. Most of that is for security reasons. Whereas an application is a program that's started and executed on your machine. So you download that and install it on your machine and then you execute it. We will be concentrating on just writing Java applications. Now, as we talk about parts of a GUI program, there are three main parts. We have our graphical components, the things that you can interact with and see in your application. There's the listener, and then there's the actual guts of the program, which we call the model. So the user interaction comes about by creating a GUI, which allows the user to have input into the program and then see output from the program. As the user interacts with the program, the GUI is going to create events to which that program can respond. So if you hit a button, there's going to be an event fired that you have clicked that button, and then you have to incorporate code to respond to that event. This leads to the idea of event-driven programming, that as you interact with the GUI, it fires or generates an event that you then need to handle if you want to respond to that event. If you want to respond to an event, you have to incorporate code to actually listen for that particular event, and then when that event is fired, you will take action upon that. You must handle events in the order that they're fired, so you can't handle them out of sequence, and you do not have to handle every event that occurs. For example, now in my particular program, I may be moving my mouse around, but that doesn't mean I have to handle every single mouse event. So I only want to handle the events that I want to take action to within my particular program. So the handling events, this is what we call listening for an event. So we're just sitting there waiting for that event to occur, and then when it fires, we're then going to respond to that. So in Java, there are a bunch of different type of listener objects to listen for specific type events. This concept of the event-driven program involves writing handlers and then writing the code to respond to those events when they happen. Listeners, this is where we set up the connection for an object to be notified when an event occurs. So if I have a particular class and I want to know in there when a button was clicked, I have to set up a listener to actually listen for the button click. And so for these, we need to implement a listener interface and then register that listener with our event source. So in Java, the Swing framework, there are several different type of listener classes. I've listed some out here. Please note that the most common listener is an action listener. This is going to be often when you're invoking a menu item and invoking a button. This action listener requires you to implement one method, the action performed. That's where then you will respond to the event when that listener has said this event has fired. Now, when we talk about GUIs, there are lots of different types of GUI controls. I want you to know that if you hear the word control, you may hear the word widget or graphical component. Those can be all used interchangeably. Examples of GUI controls are windows, buttons, menus, combo boxes, dialog boxes, text fields, etc. So there are a lot of different types of GUI controls that you can use to develop your GUI application. Now, I do want you to know, historically, the first type of GUI controls came available with the AWT, which was known as the Abstract Windowing Toolkit. That was the very first version of being able to create a GUI application with Java. You can still do that, but it's a very much outdated framework and it doesn't have that much power. So what has been developed is known as the Swing framework, which is an improved set of user interface components. It is actually built on top of the AWT, and to use that you need to import the Java x.swing and then whatever particular component class that you're going to be using. Please note, when you see X, that means that you're using a swing class. Now, when we're talking about these different type of controls, we're going to have component classes. This is items like buttons, labels, menus, and then we're going to have container classes that can contain our various type of components. For example, a window or a dialog are container classes that will hold other GUI components. So in the Swing framework, for a Swing component, note here that when you're using the Swing framework, that all the classes are going to start with the letter J. So we have J component, we have J label, J button, J slider, J combo box. And then our containers, there are several different types of container classes, but again, they're going to start with the letter J, and a common container that we'll use is a JFrame. So what is a frame? A frame is just a container window with a border that can contain other components. So if you hear the word frame, you can think of that as being synonymous with the word window. And so in Java, the JFrame is our basic building block for a screen-oriented application. When we look at a JFrame, we place our components, our buttons, our labels, etc., in the content pane of our frame. So our JFrame has a content pane, which we can access and we can add controls to. It has a menu bar if we wanted to create a menu, and then it actually has a layered pane, which gives us that visible display. So that's what you get with a JFrame. So here's a simple little window using Swing. We've got our main method here. We're going to create a JFrame object. Then we're going to set its size and just make it visible. So this simple little 3 lines of code here will actually get a frame up and visible. Then if we want to add components to our frame, again, we have to do this programmatically using the Java Swing classes. We add them to the content pane. And so there's a method within a JFrame class called getContentPane, which we can get to get our content pane object, and then we can call the add method to add our container objects, any layout managers, the components that we're going to be visible for our particular frame. Now, an example of one component here is just a J button. So again, there's going to be a class where we're going to have to instantiate a button object. Here we're setting its text, and then I can come in here and add it to my program, but then I need to be able to listen for the click of when that button is invoked. We need to implement an action listener to set up the listener to listen for when the button fires the onClick event. So to set this up, I have some example code here. We've got an application that is extending the JFrame. So we've set up our JFrame here, and we're going to say it's implementing the action listener. When we implement the action listener, that means we're going to have to add one method to action perform method, which will be on the next slide. So I've created here my frame where I'm adding a button to it. I've created my button down here. I'm setting the layout and how I want my components to be placed within the frame. I'm adding my specific button then to the content pane. Here is where I'm setting up the listener so that I'm going to listen for the click event when that button is invoked. So I say add an action listener, and the class that's going to be listening for this event is actually this class, the button GUI class. So then that requires me to come into the button GUI class and add the action performed method. So what happens when the button is invoked, this method is going to get invoked, and then I can take whatever action that I want to. In this instance, I'm just going to throw up a little dialog that says the button was just clicked. What happens if I have multiple events or multiple controls on my frame? How does my action listener know which button was invoked if I've added that particular class as a listener for all of my particular buttons? So what you need to do is there was a parameter which for the action perform method which has some information about the object that fired the event. What we need to do is we need to set up some information with our component that's going to say when this is fired, pass some information along. So you can use something called the set action command method that says when the J button is fired, the action command that I want to send with this is the word click. Then that is an identifier I can get out and see what information was passed along. So if I come here now in my action performed, let's say I have two different buttons on there. Each one I've added the current class as the action listener. So the action perform method is going to get invoked by both of my buttons. So if I use the set action command, in here, this particular event object is going to have some information about the object that fired the event. So I can then use that object and get out the action command. Once I see that command, I can say, hey, does it equal the click button? Because I said this is the message that's going to get sent with it when that particular button. Or I can say, does it equal another action command? That means another button or another component actually fired the event. So this is how I can then come into my code and respond to specific components that fired an event. As we move along here, there's a JLabel class which we can use just to set text within our frame. There are ways to create menus. A menu bar is added to the frame by using the JMenuBar class, and then we actually have to programmatically create our menu using the JMenu and JMenuItem. So here's some example code of actually creating a menu and adding menu items to it, and then adding the action listener for the particular class. That means we're going to have to implement that action performed method there. You'll hear the word layout managers as you work with the Swing framework. These are classes that help you determine the position and placement of the component that you add to a particular container, so that if you change the size of your window, it will automatically determine how to place those. This can help you take away some of the worry about the details of the layout from the user, but using these layout managers can be somewhat of a headache of trying to get controls in the right place, and you can get some really weird layouts. For example, in one of the layouts, if you use it, it's just going to make your button the size of the entire window. So they can be a little bit frustrating to use, but there are several different types of layout managers. Here's a flow layout manager where that adds components to your content pane in the order that they were added to the content pane in a left to right fashion, then it wraps them around. If we were to set a particular layout manager, we need to get our content pane, set the layout, and then we pass in the type of layout manager object that we're going to use. There are several different types of layout manager classes. The absolute layout manager class, the way that works is where you place a control, it's always going to stay there. They're not going to dynamically move around if you resize your window. But there are grid layout, border layout, card layout, grid layout, a lot of different layout managers to help you achieve the particular type of look and feel that you want when you place controls within your container. Now with these containers, there are several different types of container classes. For example, the JFrame is one type, but there are JPanels, JWindows, JDialogs. Each one of these type of containers can have a layout manager associated with it. And then you can actually have panels, and then each one of those panels can have its own layout. So I can make a JFrame that has a series of J panels, and then each one of those panels can have its own type of layout manager. And so that will help you in achieving a particular look and feel for your application. When we talk about dialogues in Java, there are several different classes that are available for you to use. For example, this is the J option pane, which you can use to display simple, informative messages, get yes, no type dialogues where you're going to ask a question and looking for a yes, no type response. There's the J file choosers, there's color chooser dialogues, there are J dialogues if you want to write your own type of dialogue. As we talk about dialogues in Java, the JDialog class is a lot like the JFrame, but it is a little bit limited. It does have a content pane, but you need to set its size and to also make it visible. And then there's a constructor flag that controls whether it's modal or non-modal. When we talk about dialogues, you may hear the terminology a modal dialogue versus modeless dialogue. Most of the time, we work with modal dialogues, and what this does is that when you click on something that pops up a dialogue, you must interact with that dialogue and hit either OK or cancel and close out that dialogue before you return to your application. And if you don't respond to that, you can't go work in the other part of your application. Then there's something called a modeless dialogue, or what we call a non-modal dialogue. That's where you can invoke that dialogue, but you're still able to go back to your parent window application and interact with that. Most of the time we don't use that, but it is useful if you have some type of ongoing process within your application. As we talk about developing GUI applications, you're going to hear the word MVC, or the Model View Controller Design Pattern. What that is just a way to organize our classes within a GUI-based application. So the parts of this are the model. This is our actual program, what we call the guts or the brains of our program. It's the one that's doing all the work. And then we have the view. This is what the user interacts with. And then we have a controller, which is going to connect it to, and that's what listens for an event, and then goes, if the event has been fired from the view, then it goes and has the model take the action, get whatever output, pass that back, and then display it in the view. The benefit of using a model view controller is that we get this separation between our model and our display. So our model doesn't care if it's a text-based program or a GUI application. It still just needs to do its computations, and then the controller is the one that's going to respond and be the connection point, so we can separate out our interface code with our model code, which makes for a cleaner design and easier to maintain our application. Please note that for a lot of applications, if you use a GUI builder, which we will use within Eclipse, it combines the view and the controller a lot of times into a single class. But there are design patterns that separate the model, view, and controller into three separate pieces. I'm going to come back and post another video here of showing you how to use a GUI builder plugin within Eclipse to help you build and respond to the events within a GUI application. In the example slides that we've ran through very quickly here, you can see it can be a little bit overwhelming of being able to even create a menu, add some buttons, implement the action listener, and all that. So there are plugins that can help us expedite the creation of our GUI and setting up the listeners to respond to our events. So I'm going to post that in a second video. I do want to say in closing here that when we first come in to developing a GUI application, it's very normal to feel very, very overwhelmed. So my biggest piece of advice is work slowly. Don't try to go out and learn about every GUI, every type of GUI container or every type of GUI component. You learn those sort of on a need-to-know basis. Start writing small GUI apps to gain your experience, and then experiment with those and build upon those, and then read and look at example code. Take advantage of Google. Go out there. If you want to know how to use the J-file chooser, use Google. Look at some example code, then you can incorporate that. Take advantage of a lot of online documentation and tutorials. Use the Java tutorials site. And the biggest thing is read, program, read, program. Read something, program it, try it out, try to gain some understanding on it. But I do want to say in closing, it is very normal to feel overwhelmed when you first start developing a GUI application, just due to the complexity and all the various ways that you can build your application and respond to the events. And I'll talk more about that in the demo in Eclipse.